All right, that was weird. I don't know if it's just my internet, but oh, you know what? I had the extra tab open. Anyways, welcome to episode 3 of RTVcron. Glad to have you all back with us again. If you don't see it on the screen, my name is Corey Wolf. With me is Matthew Nickerson, and of course, the one and only D-Sync, Vice President of RTV. Me and Matthew are on the workshop side. So glad to have everybody back for another episode of Cron. For those of you that don't know, this is what we do the last Thursday of every month leading up to DEF CON. We bring in some people to do some pretty cool workshops. Tonight we have Mike Bell, who's going to talk through Ghidra and how to use it and some fun stuff behind it. So happy to have you here with us. So for those of you that are new, we are in full swing at Red Team Village. We got all kinds of different stuff going on. As far as the core team at RTV, we're just busy. We are very busy.
Very.
Very busy. We got lots of stuff going on this week. Matthew, you want to tell us a little bit about the tactics this year? What we have some new stuff at the village that we didn't do last year. The tactics, right?
Yeah. So this year we're going to be debuting our tactics. So basically, what these are is they are short red team focused activities for attendees to sit down as they go through the village. We do have a bigger space this year, and so we're going to have places that people can sit down and hack away at stuff. Basically what they are is it's a fun, short way to get people hands-on experience with new tools or maybe something they haven't worked with. And we really want everyone leaving with something they've learned or a cool experience that they had from the village this year. So we hope it'll go hands in hands with our hands-on workshops as well.
Yeah, should be pretty good. We want to make sure that we're providing just as much hands-on activity as we can. And we appreciate everybody that's come through the village in the past. And we think from a availability perspective, the village this year should be much more available. There should be a lot more, space. So shout out to DEF CON for that. But we have the tactics. So they're hands-on things that hopefully you can just kind of check out as you're coming through the village. Try something out, hack away at something like Matthew said, and hopefully learn something new. We're also bringing something else back this year, D-Sync.
Yeah, so we're excited to announce that our party is returning this year. It's going to be on Friday, 8/8 at 7 p.m. And so keep an eye on our various social media. We'll tell you how to get signed up, get a ticket. It's going to be back at Area 15 where we had it last year. It was a whole lot of fun. Hopefully you were able to join us, and hopefully we'll see you again this year. Yeah,
that was a lot of fun. I really enjoyed the party. The music, the games, the venue, everything. So we are bringing it back. And I think basically just watch our social media for more information on the party. You're not going to want to miss it. So
we're still working out how tickets are going to go for there. So I don't want to say we're going to do like drops or whatever yet, because we don't quite know how we're going to shake that out. But just keep an eye. We'll tell you.
I peeled back. I didn't want to commit you to anything that we don't want to commit to yet. But keep an eye out on social media. Also, just some quick updates before we hop into it. I believe, Matthew, correct me if I'm wrong, or D-Sync, correct me if I'm wrong, but I believe if you've signed up to be a volunteer this year, you should have been notified. Is that right?
I believe Michael sent out the notifications last night. I think you were saying so, Matthew?
Yes. They should have went out last night. So check your spam, check the new Apple mailbox or however they organize the mail and see if it slipped by. But it should be out.
Oh, you just reminded me. You use the default mail app, right?
Oh man, yeah.
I totally forgot about that. Yeah, all right.
Someone finally told me that I could disable it, and I disable it, and it's back to the way it was. It's so much better. But I lost a lot of emails for like a couple weeks in my iCloud emails. So
yeah. So if you signed up to be a volunteer, you should have gotten an email last night. Like Matthew said, check your spam folder or whatever sketchy email you might be using. Go ahead and check it. So yeah, it also, did we actually mention if you submitted a workshop or a tactic that we will let you know by June 1, which is Sunday. So we have lots of updates coming out this week and next week. But if you did submit to do a workshop or tactic at the village, you will know by June 1. So lots of stuff going on. Very busy. Very busy. Anything else we want to cover before we bring Mike in?
No, let's get to the meat and potatoes. Yeah.
Stuff.
Okay, the good stuff. So we'll bring Mike in. Hey, Mike, what's going on?
Hi, how you guys doing?
Hey, Mike.
Doing great.
Doing good. So tonight, Mike is going to be talking through Ghidra. And for those of you that have never met Mike before, his name is Mike Bell. He was a contractor on the Ghidra team for a while.
Yeah, 8 years.
8 years. 8 years for a long time. He also helps with the junkyard at DistrictCon, which Red Team Village was at DistrictCon this year. It was their first year. It was great conference, but he also helps out at the junkyard, which is a really cool project. I'll let him talk more about that if he likes. But as you might have noticed in the con scene, he is known as the captain. So hence the hat, right, Mike?
That's right. Yeah. That's my persona out in the world.
Yeah. So I don't want to take up too much more time, Mike. I think we have your screen. We could get that up on the stream here. But as mentioned before, if you need us, we will be monitoring the chat. If you have questions, please make sure to post them in the chat, and we will make sure to get them to Mike. If there's anything that you would like Mike to go a little bit more in depth on, put that in the comments. If you have a question about something, put that in the comments. We're more than happy to interrupt Mike with questions. So same goes for you, Mike. If you need anything from us, we'll be here. We'll just be dropped in the background here. If you need anything from us, just give us a shout. We'll hop in and help you out. But let me get you set up here.
Alrighty.
And just want to say again, we appreciate it. We know this takes time, and we really do appreciate you doing this for the village. And if you need anything, just give us a shout. We'll be here in the background.
Sure. Yeah, no problem. And I just want to say thank you to Corey and Matthew and DSync for having me. On that note, I'd also like to thank Winona from DistrictCon because she got us all hooked up and everything. And in a sort of unorthodox start to this, I want to give a shout out to Vector 35, to Jordan and Peter and the entire team, because Ghidra is a fantastic free tool. And for those that are in college or don't have a lot of money, it's a fantastic way to get off, the ground and start your reverse engineering career. But if you're really doing it for a living and you've got money behind it, go and buy Binary Ninja. It's so amazing. I saw a demo of Sidekick 3.0 at Reverse 2025, and it blew my mind, absolutely blew my mind. So definitely look into that. And the last thing that I want to bring up as a shout out is to ImHex. I believe I'm pronouncing that right. ImHex. It's an amazing hex editor, and it does so much more. So go out and check that out. Those are awesome tools. So I'm going to be doing this basically live without a net. I've got no slides, well, almost no slides to show anybody. I'm going to be doing everything live. So if anybody has any questions, like Corey said, please jump in and ask, because I'm used to doing this over like about 2 days worth of time, and I'm going to be going really, really fast and probably skipping a couple of things that you might want to know. So feel free to shout out. Okay, so the first thing that I want to talk about is installing and running. It's pretty straightforward if you go to the Ghidra website, which is on GitHub. It's under National Security Agency, Ghidra. And if you scroll down here to the releases, the latest is 11.3.2 as of today. And when you click on it, you've got an installation guide right there. So it's pretty straightforward. I mean, basically what you're going to do is you're going to download the installer, which is just a zip file. You're going to unzip that, and you need yourself a JDK 21. And then you also need Python 3 if you're going to be using Ghidra. Okay. So I'm not going to go over those things in detail because there's a lot of intro guides that'll show you how to set that up really easily. But there is one thing that I wanted to show you if you've been having trouble getting Ghidra to run on Apple Silicon, because I had to do this as well. Hopefully you can see this. Yeah, my screen changed. So this right here basically are the 4 steps that I had to follow. The first is I had to upgrade Python to 3.13 on, Mac OS, because it was, I forget what it was, maybe 3.6 or something. Then I created a virtual environment in Ghidra home /venv. And the reason I had to do that is because jpipe1, the package, would not install properly unless I made a venv. And I'm not sure exactly why, but I know that was a big stopper for me. And then finally, I had to change the launch to be basically this, which is start it off with a venv and do what the launcher is doing, but in the virtual env. So you can edit your launch script. I did all that, and basically this Ghidra is an alias to that. So when I double click on it, it launches my little window there that goes away, and now I start Ghidra. Now, the first time you do this, of course, you're going to have this, help screen and the screen that says you've got to abide by all the rules and stuff like that. I've already done that. So mine is clear, and it doesn't show tips on startup. So don't be afraid if you get that stuff. So you might have gotten this far and you say, okay, well, what do I do now? Like, I don't have an active project. What does that mean? I just want to analyze my binary, right? So the way that Ghidra works is it's a little more heavyweight than some other RE tools. And you always have to have a project that you're going to import binaries into, okay? So I'm going to go and make one right now. If you go in under the File menu and say New Project. Now here it say, do you want a non-shared project or a shared one? Today, we're not going to go over shared projects at all, because setting up that kind of a server and showing that all is a lot of, it's heavyweight. So I'm just going to do a non-shared project for right now. So I have selected a directory in my home directory called projects, and you can choose whichever directory you want to put this in. And let's just say we're going to make a project named RTV. So finish, and now, boom, all of a sudden you magically have this new window that has RTV as the root in a folder structure, and you have a tool chest. Okay, so what are tools? Let's talk about this. So the front end is this window that you see right here. And anytime you're going to do any kind of reverse engineering with, like, say, looking at the decompilation or the disassembly, or do debugging, emulation, version tracking, all that kind of stuff, those are in what we call a tool. So in here, you see these default tools that get popped in when you create a project. And they're exactly what I mentioned. One is the code browser, which is sort of your typical normal reverse engineering tool. And then we've got the debugger, the emulator, and version tracking. Now, because we're so constrained on time, I'm not going to talk about the debugger or the emulator. That's pretty deep foo, but I'm going to try to hit version tracking because I feel like it's a very misunderstood or underutilized tool. But we'll start off with the code browser. So let's see, you might want to click on the tool and say, all right, I'm going to open this up now. How do I do anything? There's nothing here. Well, that's the way that it's intended, actually. from the front end or from this tool, you can import programs, okay? So I'm going to close this out and show you from the front end how you can import. So you have 3 different ways that you can import things. You can import a single file. You can import, you can do a batch import to import a whole bunch of things, or you can open a file system. Now, what Ghidra considers a file system is things like jar files or zip files or tars, etc., some kind of a container. So I'm just going to import one file. Let's do one. So because I've already used this, it's got a default, or the default directory is where I started importing before. So let's say I want to, I know about bash 4.4.18. So I'm going to go ahead and select that file to import. So what Ghidra does is figures out if the file is a format that it knows how to import, that's in some sort of a container format. It's going to pre-populate a bunch of fields and figure a bunch of things out for you and have sort of like really specialized type of loading. So in this case, it realized that it was an ELF file. It knows that it is ARM64, Little Endian 64 default compiler. And it's saying, okay, I'm going to put this in the root folder of my project, and I'm going to call it the same thing that it was called on disk, right? Now, let's say that this doesn't come up, right? Let's say it's like, I don't know what this is. You're going to end up having it say raw binary. So if you've got some sort of a ROM dump off of an embedded device, something like that, or flash, you're going to end up with this as your only choice. So if that happens, you actually have to go over here to the ... on the language, which is the way that Ghidra calls processors, and select which language that you want to use. And here you can see all of the different language and compiler specifications that Ghidra supports. Okay. So I'm not going to go over doing embedded importing today. I'm just going to leave it at the container format. So then you have some other options in here. All of these are fairly good defaults, but if you want to find out anything about this, anything in Ghidra at all that's like, well, I don't really know what it's doing here, it's pretty amazing how they have context-sensitive help pretty much everywhere. So if you hit F1 anywhere, it's going to bring up the help directly to what you were hovering on. So in this case, here are the ELF options. That's a really neat magic trick that you can show your friends, right? Pretty much everywhere there's context-sensitive help. All right, so I'm going to leave the options alone. Let's get the show on the road. Let's import this thing. So it does a bunch of stuff, comes up with a summary of what happened, and down at the bottom, this additional information is where you'll notice there are things that that it tried to do and potentially couldn't do. Like, for instance, lay down these ELF notes, said there was a data conflict there. Also not found in project are these shared libraries. It turns out that it'll do linking of your binary versus shared libraries if they're already in your project. I'm not going to do that. Just going to show off bash as it is, and I'll show you where the disconnect is. So we say okay, and now you'll find in the RTV folder there is bash 4.4.18. So what do we do now? Well, we can open this tool, right? And once again, there's nothing in there. What do we do? Well, turns out you have to either double click on this guy or drag him up on top of that dragon. So I'm going to drag him up there. And now it opens up, okay? So the first thing Ghidra does is asks you, hey, do you want to analyze this thing? its first import. Nothing has been done to this thing other than what the loader has laid down, which you can see in the background here is like the ELF header and some other data structures. So do you want to analyze it now? Yes. Let's go ahead and analyze. So here is a myriad of different analyzers that can be run on your binary. The defaults are pretty much good for anything that you're going to be running on a container binary, such as ELF, PE, COF, etc., Mako. Just leaving these alone is going to get you fairly good results. So let's go ahead and analyze with the defaults. And down here, you'll notice the progress bar. It kind of goes back and forth with all the different analyzers that are running. So you can't really trust it because it keeps recycling over and over again. And should be pretty fast. It's an M2. I didn't time this out last time. Live demo. All right, there we go. So auto analysis is now finished. And you can see it's moved us to main, which is the primary entry point for Bash. All right. So let's see here. All right. So the first thing that we're going to do is we're going to go to the main window, which is the listing. Okay, the listing is in the center, and it's what shows you the disassembly and everything else that's going to be going on in your lowest level of the program. Almost everything else is sort of built up from there. So when you scroll down a little bit, and I'm using the mouse scroll wheel to scroll down, you're going to see mostly what looks like normal disassembly, right? On the left here, you've got an address. Then you have the bytes that were disassembled at that address. You have the mnemonic or instruction. And then you have the arguments, the operands to it. Okay. So because I have very small screen real estate, I'm going to sort of make this window a little bit bigger. And it's got a standard little thing you can hover on there that shows you resizing the window. All right. So scrolling down a little bit more, there's this other thing here called XREFs. Okay. So this is cross references. So when you double click on one of these cross references, it will take you to that position. So it's kind of like a tunnel to jump back and forth between them. So here it took us to a branch. We'll double click on the branch, and now we're back to where we started. So let's see here. Where is my... Okay, so you see this guy right up here? It's like a little box with a pointer in it. This is what turns on this this action, which is basically a hover pop-up. And that can kind of get in your way. It can kind of annoy some people, especially when they're trying to present, like, on the world stage. So I'm going to turn this off right now. And so now when I hover on things, it shouldn't bring up that box anymore. But if you want it, then this is how you would turn it back on, is right here. Okay. So let's scroll back up a little bit and get to main. Oh, I'm sorry. I'm in a different function now. Parse ComSub. Okay. So I said, let's go to another function. How do we know it's a function? Well, there's this big plate comment up here that says that it's a function, and it's got a nice parameter list and return type, and it's got basically where the storage is for these things. and the stack layout. So then you'll see if you scroll down a little bit more here, you've got this parse com sub, right? This is a label. So if you come down a little bit further, this is what is called a function label. But you can have other labels like these branch labels, right? So that's another feature that you'll see in the disassembly. It's very similar to other reverse engineering tools. Another thing that I'll go over real quick before we start moving on to modifying your view of all this is comments. So the semicolon allows you to enter comments. You don't have to remember that. I will explain that again later. But right now, unfortunately, the highlighted color is almost completely invisible. It says EOL comment right there for those who can't read that. So I'm going to make an end of line comment. This is my comment. And I'll say okay. And you see that over here, my comment showed up. Okay. So why am I showing you all these different components? The reason why is that these things are basically all customizable. You can drop down this field, listings field box right here, and everywhere that you click, it will auto-navigate to the template basically for what part of the listing is responsible for rendering this content. So like, let's say the bytes is a little bit too small. You want to have a little bit wider area for the bytes. You can take this and you can drag it over. And in real time, the spacer and the mnemonic are going to the right, which is pretty cool. Same thing with the address. Let's see, where's the EOL comment? Here's the EOL comment, right? So if I wanted to bring that a little bit closer towards the operands, I can do that. So keep this in mind. Another little tip and trick, you'll notice that in the default layout here for instruction and data, there is this P code that is grayed out right now. That means that it's disabled, okay? So you might wonder what P code is. Real short, it is a register transfer language type of thing that basically is what the decompiler uses to be able to create its magic. And so we'll talk about that a little bit more. But if you wanted to see the P code, you can. The field is here. All you have to do is enable it. So if I right click and I say enable this field, then all of a sudden you're seeing all of the P code in here. Now, why might you want to see the P code? Well, let's say you're not very familiar with a particular instruction set, right? And you need to know, well, are the status flags updated, for instance, with this particular instruction? Here, you can drop down, show the P code, and it turns out for this version of add, yes, as a matter of fact, they are, because you see all of the int carry, int s carry, etc. For updating those status flags. So also, it's, believe it or not, it's a way that I actually learn other languages, other processor architectures, is by showing the P code. And because I know the P code pretty well, I kind of know what's going on in the actual assembly instructions. So I'm going to turn this off now. Okay. All right, so there are a bunch of other things you can do with the listing. I'll sort of show some of them now. If, oops, sorry, scrolling too fast. Let's say that you want to track the a particular word or register or mnemonic, anything basically, and do matching. You can do that with the middle mouse click. It's one of the reasons why I have a mouse hooked up right now instead of using the trackpad, because it's a lot harder to do a middle click with a trackpad. But let's say I want to see a bunch of STPs, right? If I middle click, it'll show me all the STPs. Or moves. Do I have any more moves? No. Actually, I don't have a lot of the same thing. But anyway, let's say that I wanted to look for nulls. I can middle click on this null and it'll show me everywhere that there are 2 zeros together. If I want to highlight parse.y, it'll show me that, right? So that's really cool. It's a nice feature. But what's more amazing is when you do it with registers. So with registers, it'll show you what the lifetime of your register assignments are. This isn't one that's very fun. Let me see if I can find one that's a little bit better down here. Yeah, actually, that was pretty good. QC. Yeah, there you go. So here you can see where first use is made after setting. So the assignment here happened on this line at 56AC. And this is the first use, and then other references are just in yellow. So that's a really cool trick if you haven't done that yet. Let's see, another thing is right-clicking anywhere, you're going to get a context-sensitive menu. So here I am on an operand, and I get, basically all of these things here are something that I can actually do at this location or field in the listing. So let's see if I can show you another one here. Yeah. So when I let's say I show this 10 here, right, which is 16. So if I right click on it, I have a convert and it says, oh, okay, well, this is unsigned hex. It's 0x10. It's unsigned decimal 16. But if I right click on this parse.y, it doesn't show me any of those because, again, the right menu is context sensitive. Okay, selection and highlight. So let's say that I think that this is wrong in here, okay? I want to do something like clear these instructions. Well, the way that I would go about doing that is by making a selection, and it's pretty easy. You just use the left mouse and you drag across your listing for the extent of the selection you want. If you have multiple different pieces, you can do that. You can hold down your, in my case, it's Command, but if you do Control on a PC, it's going to allow you to do multiple selections. And now, let's say I go and I just want to clear the code bytes there. Okay, it'll do it in both those locations, but everything else is intact. So selections are a way to invoke actions that are specific to what you want to have happen and not everywhere else, okay? The thing is about these, though, if I go and click somewhere, now all of a sudden my selection went away. So that's not cool. What if I want to get it back, right? Well, like I select another thing and I can't get it back now. So what you can do is you can select something and right click and say program highlight the entire selection. So now you have this yellow region that doesn't go away when you click somewhere. And that's a way for you to have a selection that's sort of saved in a single register, like a single register, not not a program register, but in Ghidra land. And then to restore it, you can say program selection, entire highlight, and it'll bring it back. So that's the very basics of selection. Something I haven't shown, obviously, is undo. I went and cleared these code bytes. I don't really want to because it turns out those were great. So I will say undo, and the code bytes come back. Notice, of course, the highlight is still there because that's in a separate register that isn't part of the undo stack. All right. So let's see. Gone over those. Let's go over. Actually, hold on. Let me check in with Corey and see. I've been running my mouth for a while here. Is there anything we should check in with?
I think Corey's away at the moment. Everything is good so far. We don't have any questions in chat, so I think you're cooking along. Everyone is keeping up.
Awesome, fantastic. Okay, so searching for bytes. Let's say that we want to search for the. Okay, we think that there are some strings in here. We're going to search for the. What you can do is do search for memory. And in this combo box right here, it defaults to hex, right? And that makes sense if you're looking for particular values, constants that you think should be in the binary. But in this case, I'm going to take it down to string, and I'm going to say the, and we'll search. And boom, oh my God, there are billions of matches. It stopped at 500. You might say, well, what if I want all of them? Well, it turns out, let me just shut the search memory down for a second. You can go under tool options, and we'll search for match down here in the filter. So search, reference search. Oh, search. There we go. Search limit. So it told me it stopped after it found 500 matches. Let's say I want to bring that up to, say, 50,000. That's fine. All right. So let's do it again. And we'll search for that. And there are fewer than 50,000. Turns out there are only 689. But this is the way that you would search for things based on actual bytes that are in your program. So at any point, I can click on one of these entries in the table, and it'll take me directly to that point. All right. So let's say that's not what you're looking for. You want to find moves, right? You want to find this move instruction. How do you do that? If you search for move, you're not going to find it in the text in the binary itself, right? So that's what search program text is for. So let's say that I want to search for move. I'm going to check the, we'll say listing display. And right now the selected fields are just comments. I'm going to say all fields. And we'll search all. Now it's probably going to stop at 50,000. Yeah, I was kind of silly. So I did the listing display, which also will bring up strings, which I haven't talked about yet. But this is sort of where what I wanted to show is that you can find the preview in the search window that shows what you're looking for. So like if you're looking for a particular ROP gadget or something like that, the hard way, you could do it by searching text. Okay. Search for strings. All right, so a lot of strings were already decoded because of the symbol information. The way I can tell you that I know that's true is if I go down here and say define strings, this comes up and it's incredibly small, and that's kind of annoying. So I haven't talked about the actual window manager yet. So let's do that. The window manager allows you to take things and replace them. So this guy here, I'm going to bring out into its own space. So I'm going to drag it until, let's see there, until it looks like a little window. I don't know if you saw that. That was pretty fast. Let me put it back in and tile it with the listing first, and then I'll show you. So this is in its own window, right? You can't remove it, or you can't resize. What word am I looking for? You can't move it to another place in Ghidra land by its operating system window bar. You have to click on this thing here. So I'm going to take this, I'm going to drag it down here into the listing, and now you can see it's actually a tab. So I can go back and forth between them as tabs down here underneath. But I don't want that, okay? So I'm going to slide this down and show you all the different icons. So see that there? That little 3 boxes thing means create a tab. And this little arrow thing that you can see right there means tile it to the right. And you can also tile it to the left, or tile it up or down. Okay, so like let's say I wanted to have 2 things here and put the string window on top, I can release it, and now the strings are up there and the listing is small and everybody's unhappy. But the last one is to make it into a real window, which is right. Oh, come on, I just had it there. Okay, so it looks like a little window with a title bar. Okay, so big detour there. Let's come back to the defined strings. So we have quite a few. We have 7,000 of these guys. And a lot of these are from the symbol table. And eventually, holy moly, we have a lot of them. Eventually, we'll get into these things, which are actually in the actually, you know what, I'm not sure, these might be referenced by somebody else, but anyway, somewhere in here there we go, somewhere in here we're going to get some actual data that is referenced by the code. So we have a bunch of defined strings, but let's say you don't. Okay, let's say that you brought it in as an embedded target, and you don't have any strings because the container format is non-existent. So what can you do about that? Well, you can search for strings, and this has basically a nice trained word model. I'm not sure if there are any others. I'm not going to click here because I'm scared. I don't think that there are any other ones. Let's see. Yeah, see, I don't have any other ones, I don't think. Anyway, defaults are pretty good. So I'm going to search, and a whole bunch of things come up. So up here in this top title bar are a bunch of filter buttons. So it says show defined strings, show undefined, partially, and conflict. So I'm going to turn off all except the undefined strings. And what this shows is all of the things that Ghidra in that string model think that are strings that aren't actually defined. So let's take a look and click on one of them that we think should be defined, and that's memory exhausted. So this is in what location? Debug info. Okay, so I was wrong. Let's see if there's any that we can find that are out of debug. Aha, okay, there we go. So for some reason, this undefined 8, oh, well, probably because, yeah. Okay, so it's a compiler optimization. It turns out that this right here is looked at as a quad word, but it should just be a string. And the straightforward analysis didn't pick that up. Let's see if there's another one. Yeah, this one is probably some sort of other, like an indexed offset type of array. And because of the static analysis that it does, it didn't pick up the fact that this is actually a string because it didn't have a direct cross-reference. So anyway, that's how you would go and look for strings if you have an embedded target. Okay, so let's talk about address tables. So address tables are fantastic. You get them in for all different reasons, for case statements and V tables and all kinds of good stuff. So let's show that. Let's search for address tables. And we'll say minimum length is 3, alignment has to be 4, and we'll search. So it turns out that there are not a few of these in this program, which is kind of interesting. Oh, by the way, so let me just take a second to tell you a little bit about me and my RE skills. So I have very, very attention deficit syndrome when it comes to doing RE. I am not meticulous. I'm not methodical, which is really a detriment in some cases. And in particular, I have not really looked at these bashes beforehand in order to familiarize myself with them. So I apologize for all the things that I'm discovering because I really don't know. I haven't looked at these at all. So anyway, I look at, usually sort by the length. Oh, there's an inadvertent thing. That was actually later in my presentation. Whenever you have a table, you can click on the top, the one of the labels, the column labels, and it will sort it for you. Not only that, but if you control click, or in my case, command click, you can make secondary sorts. So you can tell primary from secondary and then change their direction by just clicking on them again, which is pretty amazing. So sorting them in decreasing length, it turns out that most of these things are already labeled, right? So where are we? Signal names, DC string. Yeah, this is defined data that is, it's pretty amazing. But yeah, I don't know why that is, oh, it doesn't, oh, because it's part of another one. Okay, yeah. So anyway, basically the upshot is the debug information that was included in this particular executable was so good that it got all of the address tables that we're going to find. But for analyzing binaries that, like I said, don't have a container format, this is going to be invaluable for you to find runs of pointers to functions or data that is going to sort of kick off and be able to help you find your entry points and you know, the hidden functionality of your program from a static perspective. All right. let's go and see. I showed you the fields editor. All right. So real quick, let's go to the entry point. So G is the key shortcut to do go to. So I'll do G and say I want to go to main. Now I'm back up at main. And let's say that some of this stuff up here is really, really interesting to me. Okay. So I'm going to say, you know what? Right here, this branch to free, I want to make a bookmark here. I want to be able to go back to this later. So if you right click, you can see this thing bookmark, which for me is Command D, for you it'll be Control D. So I'm going to make a bookmark here, and I can put a category if I want to be able to sort it. And I'll show you that here. Let's just say demo category. And then I'll say this is where the free is. Okay, so I say okay, and now you'll notice over here in the listing, there's this little purple check mark. Up here, display the bookmarks table. That is the little icon that'll give you the bookmarks. So let's click that. And of course, what it does is it tabs it along with the console, which I'll talk about later. Okay, so I have a huge number of bookmarks in here, and you saw me only create one. Why are these here? Well, it turns out that analysis and errors and that kind of stuff pop up in here as well. So if you don't want to see those and you only want to see your bookmarks, go over here to this adjust filters, which looks like a little wheel, and you can click the other ones off and say, I don't really care about all those. I just want to see mine. Okay. So you'll notice that it has a category here. You can sort by category, or you can sort by description. So the category is just another way for you to organize your thoughts as you're laying down these places. And no matter where I happen to go in the binary, I'm down here looking at these frame descriptors, and I'm like, oh, where's that free? And you just click on it, and it'll take you right there. So let's say that I hadn't bookmarked where that frame pointer descriptor was, and I want to get back there. How do I do it? Well, up here is an arrow that'll take me back. So this is your entire navigation history. Well, within reason. I think it's like 30 or something like that. I forget what the how many are in there. Okay, so let's bring up the string table again. Define strings. And to filter, you just go and type in this filter box. So we'll say, I want to filter anything that has the in it. And sure enough, it comes right up. Now, let's say you need to make other kinds of filters. Like I want everything that doesn't have filter. I can invert it. I'm sorry, anything that doesn't have the, I can invert the filter. So invert that, and now all of these don't have the in it. You can change it to a regular expression. So we can say the there's no there. Oh, there is. What did I do wrong? I'm suspicious. Do I have to escape it? Nope. All right. Well, I'm doing something wrong with the regular expression syntax, but trust me, that does actually work. How about there? There we go. I fail to see. I guess these are fairly long. Arguments using, oh gosh, yeah, these are really, really long. So it's somewhere in there. Anyway, so that's how you can do filtering on tables. And that should exist on any table that is in Ghidra. All right, let's see where we are here. Okay, the symbol table. All right, so symbol table is this guy right here. And this is kind of nice because it's going to show you every single defined symbol in your program. Things like, so it's sorted on location right now. But things like what's the reference count? What's the source? Turns out almost all of these are imported right here, right? Analysis, put down a bunch of case labels. What else? Some of them are default, right? So I clicked on this guy right here, this function. Why is this called a default symbol? Well, Ghidra knows that there is some kind of a function here, but it doesn't know what its name is. And the reason why it knows is because there's some sort of a branch link somewhere that came to it. At least I believe so. No, there isn't. That's interesting. I'm not sure exactly why it thinks that this is a function, unless there was an entry point, but then it should have had a name. Oh, it's part of debug. Interesting. Okay. Yeah, I'm not 100% certain why that's like that. Let's find another default. Real quick. See if that's a bigger one. Are you? Oh my God! I can't believe I selected the same one. No. All of these are little knops. I don't know what the deal is. I'm off in La La Land right now. Anyway, the point is that these default symbols are what Ghidra assigns when it doesn't know that there's a name. So we can see here, this is a default symbol. It's a label. Now, let's say that I don't like this name. I want to rename it because I know what it is. I can edit the label here with L and say, this is my label. Okay, so now this is my label will show up in the symbol table if I go and filter. And you'll notice it's user defined. So anytime you make a symbol, be it by renaming a label or a function or a piece of data, etc., it's going to show up in the symbol table as a user-defined one. So obviously, if you sort by the reference count, you will find interesting functions like free and malloc and so on. All right, I'm coming up on 50 minutes, so I'm going to motor through these. Let's see what's my next one. Okay, so program trees. The program tree is a way to look at your data, or I'm sorry, look at your sections in your code in a different way. And honestly, I almost never use this. And this is because I see squirrels. Okay. I get distracted by things super easy, and I don't actually go through things methodically. And the default view of the program tree is very similar to what this memory map is, right? So you open the memory map, And you're going to see things like the BSS and the interp and the RO data and PLT and all that kind of stuff. So if I need to go to a section, I almost always use the memory map to go there, and not use the program trees. So I apologize, all of you who love the program trees. I don't use them that much. Symbol tree as well. You can find things in here fairly well. Like let's say if I want to find free, it'll show me all the things that are named free. Pretty fast too. It's very fast. But I also don't use the symbol tree that often. So I apologize to those who use the symbol tree a lot. Usually I use the symbol table, or I use bookmarks. All right. The data type manager. Oh, this is a beast. Okay. It would be completely and totally irresponsible and remiss of me to not do something with the data type manager. So I will, but this is probably a lot less adequate, very inadequate for those who really want to have a deep dive. But basically the data type manager allows you to use these, what are kind of like templates, this defined data structure, and lay it down on bytes in the listing. So let's say that I happen to know that I've got on this cut right here, I happen to know that this is an int, right? So I can go to the built-in types and I can say int, which happens to be a favorite. I'll show you where that is. And I can lay it down right here. And boom, now this location has defined data in it, whereas before it was undefined and it was just a string of bytes. That heart is where where you'll find it in the menu. So let's say right here, I need another int. I can right click and go to data, and I can choose int off of this list. And boom, it'll make an int there. Or I can make something else. I can say this is a, you say a quad word, right? So this is an instance where, let's say I don't want my quad words to look like this. I can drop this down and say for the bytes, let's space that out just a little bit more. It's probably me. I probably left it in a bad state. Okay, so you might say, well, all right, this isn't that impressive. Why do I really care? So let's say here we've got a U short and a short and another int. And this happens to be a structure. I can go and click on all this here and select it and say, I'm going to create a structure, which is shift left bracket. So create a structure by name or use an existing structure. These are all things that Ghidra already knows about, that have been imported and delivered with Ghidra. I'm not going to use them. I'm going to call this thing demo struct. Okay, so now all of a sudden, all those things went away. It says demo str, which that's not wide enough. So let's make the mnemonic a little bigger. Okay, demo struct, and you'll notice there's a little plus here, and that's to expand it. So if I want to see what's in the struct, now I can open it up and it'll show me what it is. Not only that, but it's named. Okay, well, what are these names? How do I get here? What happened? Well, let's go and edit this thing. So if I right click here and I go data, I want to edit that data type. It brings up this fabulous structure editor that allows you to change the names of all your fields. So let's say this is one, whoops, sorry about that. 1, and this is 2 and 3. By the way, what I'm doing there is pressing the down arrow. And so now I've changed this in the editor, but I need to save it for updates to occur in the listing. So right now it still says field 0 through 5, whatever, with the offset. Now that I've named them and I save, it updates this in real time. What's amazing here is that you can define bit masks or bit masks. What am I trying to say? Bit fields. Gosh, sorry, brain is out to dinner. Yes, you can define bit fields in here. Right now, it's just showing you the that each one of these are 8 bits within each byte, and then it's shows you the component byte offsets for each piece. Yeah, you can actually do C++ style or C style bit fields in here. All right, so that is like super, super fast what the data type manager is. You can, let me get rid of this here. You'll notice that there are 3 different books here. The data types go in these libraries, these books essentially, and you can create new ones and you can share them. So definitely read up about this data type manager. Let's bring up help, because I always love showing off context sensitive help. Brings you right to the data type manager. Please read the help. It's very, very in depth, and it's amazing what the team has put into this. Okay, where am I? I'm coming up on an hour. Oh my gosh. Yeah. Okay. So it's time to talk about the decompiler. How we doing, guys? That good. All right. So I made the window a lot smaller to give us more of the listing view. But now I'm going to make this bigger to show the decompiler. Again, doing streaming with a single screen, it's going to be very difficult to show this kind of stuff. But this is the Ghidra decompiler. And what it is doing is using the P code. Sorry, let me scroll back up to where this is here. It's using the P code to basically reverse engineer what it thinks the C code should have been for the assembly that is being shown. And it's very, very powerful, and you can sort of influence it to do things the way you want to. But there's a lot of arcane kung fu that's going on behind the background. So some of it is a little bit esoteric, to say the least, in terms of trying to figure out what's going on. So the first thing that you'll notice here is that you have local function variables that are named according to their type, essentially, right? Or they're named according to what the library is. So if I look at format here, the reason it's called format is because this fatal error has format in its function signature as the first argument. So these guys here, it doesn't know what to call them. So it says, it's a pointer to void variable 1, pointer to void variable 2. But you can go and rename these things. So rename it and say, I don't know, this is foo. And now everywhere where it was before, it's renamed foo. Looking over in the listing, you'll notice, well, none of these things say foo. So what happened? Like, where's the disconnect between these two? Well, it turns out that you haven't committed locals yet to the Ghidra database. So if I say commit local names, now you'll see that X0 is foo, right? And X0 is PVVAR1. So what does that mean? Well, actually, that doesn't make sense. Yeah, there's something a little bit goofy going on there, because this PVVAR1 is subtracting foo, which it's saying is the same var node. I'm not sure why that's going on. I'd have to look into that a little bit more. But anyway, what I was trying to say is that registers can get reused they can get reused by different variables within the same function, right? That's how the compiler works, is it can reuse these things. And what the decompiler does is tries to ferret out where those things were and call them different names based on their usage lifetimes. So let's see here. Let's see if we can do so we can do highlight based on slicing. So I want to figure out where the slices are for this. And it's saying that it's here, but why? Let me go back up here to highlight backward slice here. Foo is outbreak, S break. Maybe this will give us a little bit of insight. Sorry to go off on this tangent. I'm just really confused by what I'm seeing right now. All right, I'm going to stop and arrest myself here from this and move on to say that one of the most important things that you can do to get your decompiler output correct is to run this analysis, which is decompiler parameter ID. And so what this is going to do is, from the leaves, which are assumed to be correct, their function signatures, it's going to propagate all of that stuff up through all of the non-leaf, the interior nodes of the call tree, to basically fix all of the types that are in there. So let's run this guy. And nothing has changed. Was it in, maybe it was in my, no, it wasn't. Interesting. Okay. Well, it didn't happen to change anything in malloc. Let's see if we can get to another fun function. Did you see that? So Ghidra will let you know if you already have a window open. Like if I select the decompiler, it'll go and do it again. It'll shake it and say, hey, I'm here. At least it should have. Weird. I'm not sure why that's doing that. It's supposed to do that shake thing that you saw the first time. All right. So none of those thunks are going to work. Free string list. Let's take a look at this. Yeah, so now you can see these parameters, sorry, not parameters, these locals now have the appropriate structure pointers in them because we ran the decompiler parameter ID and it filtered back up from them. All right, so I'm really getting low on time here in terms of what I wanted to cover with version tracking in BSim. So let's take a peek here. Two more things that I want to cover real quick. One is the bytes, display bytes. What is this? Okay, well, this is kind of like a hex editor. It's definitely a hex displayer, right? So by default, it's going to come up with 16 bytes per line. And you can configure that with this little wrench here and say, okay, well, I want 16 bytes per line. My group size is going to be, let's say I want 2 because I want to see shorts, right? So you can configure it pretty much any way you want with, let's say I want to have ASCII as well, right? So it looks kind of like a hex dump kind of a deal. But if you want to edit anything, you can try to edit things. And I'll show you why I said try in a second. So this little right thing up here with a pen or pencil, this is what you need to do in order to start changing bytes. So I pressed it in, and now let's say that I want to make all these zeros. Okay, down here you'll see editing not allowed, an instruction exists there. So Ghidra knows that you've laid down a code unit there. In this case, it's an instruction, but it could also be data, right? Defined data. And it's going to not let you edit that until you clear it. So if I go and clear these 16 bytes here, now you can see over here, you've got the question marks. There's nothing that's laid down there. So I can go now and edit this to my heart's content, and it'll show it in red. What is my... Oh, that's hard. There we go. Okay. So it's in red. If I went and tried to disassemble this again, so I disassemble right here, it's undefined, right? So it won't continue. But you'll notice all this is still red. The reason why it's red is because it's changed and I haven't saved. Okay. If I save, then I don't want to do that right now because it'll screw up my whole undo stack, right? Is that right? No, I'm sorry, not my undo stack. What will it screw up? I can't remember.
Mike, I have kind of a question.
Yeah, sure. What's up?
Why would we want to edit that data?
That's a good question, honestly. anytime that I've ever done editing of data, it's been outside of Ghidra. One of the primary limitations of Ghidra is that for container formats, you can't actually reserialize the data back to disk. So if you bring in an ELF or a Mach-O or something like that, if you were to change pieces of it, you can't just go and say, save this, and now you've got a new ELF or a new Mach-O. You can export things, but yeah, honestly, I don't ever use that.
Yeah. Well, that was my next question. Like, what happens if you edit it and then you save it? Sounds like you couldn't just. It wouldn't. The ELF wouldn't work, right?
That's correct. Yeah, that's absolutely correct. When you export the program, you can export it in like raw bytes. It says original file, but I don't think that actually works. I'm 99% sure that it doesn't actually save in the same format. Let me see if that's correct. Watch me be a liar.
We'll do it live, Mike. That's what.
Yeah, we'll do it live. That's how we do it. Yeah. See, I lost my undo stack now that I've saved. Okay. Or redo. Yeah. So let's clear this out real quick. And we'll 0 it. And then we'll save it and we'll export it. What are we at? 132,890. Maybe I am a liar. Oops, sorry, I need to import it. Wow. I am a liar. And I'm almost positive that worked based on what's going on with the analysis. Okay, so I am shocked. I'm very, very surprised. So I guess that is one reason that you would want to use it, is if you're trying to short circuit some kind of a loop or something like that, or some other part of a decision tree. You could change the bytes, redisassemble, make sure that it looks like it's doing the right thing, save it out, and then run it again. Probably something for CTFs.
Yeah.
Yeah. Good question. I'm really glad that you did that, because I learned something new. Well,
so here's I'm terrible at reverse engineering. So, but like, here's a question: like, what if? So you saved that, and then you brought it back into Ghidra, but how do we know? I guess the question is, would Ghidra still load it even if it wouldn't actually run? Like, what if you tried to execute that binary?
Oh yeah, certainly. Yeah, Ghidra will definitely load it, even if the executable won't run. Just because, like, to Ghidra, it's all just data, and it's trying to interpret the data the right way. But when you have a program, and you have to forgive me for going in the Unix land, because that's what I'm most familiar with. And you have the loader, right? Like the actual interpreter load the program off disk and start running it. It has one world view of what all of the fields and sort of the metadata around in the container structure that is the ELF, right? And it's all designed to help the Linux kernel figure out how to run this. Well, Ghidra tries to have the same sort of view of things, but it has to be different necessarily, right? Because like people will write malware and dork with the ELF headers, right? And clearly you don't want the malware to like somehow execute on your in Ghidra. So it's interpreting what it thinks the values are in the best way that it can. But it's kind of like a Venn diagram, right? There are things that the loader might support that Ghidra might not, and vice versa. If that makes any sense.
Yeah. No, that makes total sense. Thanks.
Sure. Yeah, absolutely. Yeah. So, wow. I'm just shocked. Where were we? 132,890.
That's a good memory, Mike. Good memory.
Oh, no. I had to go back and look. I've got zero memory. Yeah, look, it's there. Unbelievable. Undefined function. Yeah, so wow. Kudos to them. I'm gonna have to go and tell them they did a great job.
Nice.
Okay, so that's the bytes. The last thing that I wanted to hit real quick before we get into version tracking is the script manager. Okay. So what's really amazing about the script manager is that it lets you programmatically enhance Ghidra and do your own things. And as you can see, like this is a blank slate here. In other words, like I'm only showing the scripts that came with Ghidra. You've got just a ton of them. And so open these guys up, take a look at what they do. Look at how they do them. Most of them, of course, are written in Java. Some of them are not, right? Like you've got this Python script, you've got generate signatures, Python, etc. Ghidra basics. So definitely dive in and try to do stuff with scripting because it's amazing what it'll open up to you. So let's go and edit one of these things. You can launch it with Eclipse, which I don't have set up, or you can edit with a basic editor. So a basic editor just brings up a little window that's docked in here, and it lets you edit this and save it and then run it. But like here, you can see this is using the Jython runtime, which is built into Ghidra, or built in by, like it's always able to do Jython. You can tell that it's back on 2.7 because you'll notice the print is has no parentheses. So this shows you how to interact with the Jython runtime. Also, then if we go down to Ghidra basics, here we go. Let's edit with basic editor. There we go. So this shows how to do it with Python. That's the 3 point whatever, in my case 3.13, and it uses JPipe. Okay, so that's like you have to figure out sort of how to what the difference is between the way Jython interfaces with Java and JPipe. And this is a great thing to look through and see, okay, this is how it works. Yeah. So, I guess to take a step back before we go to version tracking, a tool like Code Browser is essentially just a collection of plugins. Okay. Each one of these things, like say the bytes viewer or the decompiler is pretty extensive, but each one of them has like this thing that is a plugin. And a plugin is very heavyweight. You have to write it in Java, and it's got a lot of things that sort of go into it. But with the script manager, it's pretty amazing. You can go and this is a bad example. Let me go get another one real quick here. So hello world script, you can see it's got a key binding. So not only, there we go. Not only can you give it a key binding, but you can put it on the toolbar and give it a menu path, right? So you might say, well, I don't see this. How come it's not up there? Well, the reason why is that it's not in the what you call it. It's not in the tool, right? So over here in tool is false. So I'm going to click on this and say in tool is true. And I think you notice that right up here, this little guy came up. That is writes hello world to console. So if I shut this down and we bring the console back here, I click on it and it says hello world. And also underneath, now I'm a liar. Where is it? It should be, there should be a, what was the path? The path was help examples, hello world. Okay. So help examples, hello world. And it's also control shift comma, right? So if I do that, or I do control shift comma, it runs, right? So yes, scripting, amazing, fantastic. Look into it. Okay, let's talk about version tracking. So this has changed. I don't want to save it. I don't really care about these. So let's talk about use case. When you want to see what are the differences between one program and another, you can use version tracking to let you sort of make those determinations of like which functions map to the new functions and be able to propagate that data. Okay. So like, let's say that you have a whole bunch of function names that you've worked out and comments and labels and bookmarks, all that kind of stuff, right? And you get a new version and you're like, man, I really wish that I had this marked up the same way that I have the old one marked up. You can use version tracking to help you out with that. So I'm going to open a new project. It's going to be the bashes or VT pre-baked. I apologize that I'm not doing all this without or with a net, but I put these in here already just so that it saves a little bit of time. So what I have here are two different versions. And the crazy example that I'm going to show you right now, why this is so powerful, is that one is an ARM-based bash and the other one is an x86-based bash. Okay. So we take these two programs and select them and now drag them onto the version tracking tool. So the wizard comes up and says, what is it that you want to do with these programs, right? So first we have a project folder. We have the session name, which is basically what it's going to be stored in your project. And then you have the source program and destination. So it turns out that I lucked out. The one that I have that still has all the debug symbols in it is in the source program, which is the ARM one. And then the x86 that I stripped is the one that is in the destination program. So this is the correct order. So I hit next and it's going to say, well, let's look at the preconditions. Let's run a couple of things and just to check to see if you're on the ball. So I'll go ahead and run these things. But I know that some of these things are going to come up as warnings. So first of all, memory blocks validator. Well, the fact that these are two completely different architectures means that their memory blocks aren't going to be the same. And number of no return functions, there are 15 and 9. That's really not that big considering the number of functions that are in the thing as a whole. So I'm not going to worry about these things. I'm going to say next and finish. Okay. So you might say, what is going on? Well, it pops up 3 new windows. One is a source tool. One is a destination tool, which you can't even see because it's over on my other screen. There we go. So I have a source tool, I have a destination tool, and then I have the results window, the actual version tracking window. So what I'm going to tell you is the source tool has the source program in it. The destination has the destination tool in it. There are matches in the bottom right below the decompiler on both of these windows. They allow you to navigate once you found these matches. So this is fantastic if you have like 3 monitors or 4 or whatever. You can put one of these in each of your windows. For tonight, I'm just going to put these into the other window and show you the main screen. All right, so there goes the source tool, there's the destination tool, and here's our version tracking window. All right. So when you first start off, there are those that that would disagree with me on this, but there's something I think that's very important, and that is there's a feature in tool options under version tracking called accept match options. And in here is this checkbox, auto create implied matches. This doesn't work well. Like I said, it's a little controversial, but I always turn this off because it'll help declutter your answers, especially when you're doing something kind of strange like what I'm showing you, tracking from ARM to x86. Okay, so the next thing that I'd like to steer you away from, if at all possible, is the automatic wand, which runs several correlators and applies good matches. So if you read about it in the help page, it's trying to do something that will save you some time. But if you really get to know these correlators, you'll understand the right order to place them in and the things that you need to do beforehand in order to get them to work for you properly. So I'm going to start off with what I believe is the absolute best correlator. So you might say, what's a correlator? All right. What we're doing here is we're basically trying to correlate things from the source to the destination. And we've written these things called correlators. They're actually the program correlators. And they look for functions or data or both and try to make this mapping. So the way that you run one of those is by using this plus to add an additional correlation. So I'm going to select this guy. And the first thing that would be always on my list to run is exact data match. So what this does is it looks for data in both programs that only exist once. So if you have, like, say, 2 strings that say /bin/sh, then this won't find it because it's duplicated. It has to only be one definition per source or per destination. So it's a great way to start off with one-to-one matching. All right. So data minimum size. The reason why this is 5 is because almost everything that is that you have addresses for in a program, at least for these, is going to be 4 bytes, right? So we want to up that just a little bit and try to make it reject all the things that are just ints, right? So this is basically trying to find things that are like strings, right? All right. So we'll ignore this for right now and we'll say, let's go. And magically, we have 3,600 matches. If you were to go and select these guys, it'll show you in the listing view, which is right here. It'll show you what it looks like in the source and what it looks like in the destination. So in this case, this bash maintainer at gnu.org, the symbol got stripped off of it, right? So it has no symbol. Most of these are still intact because of auto-analysis, because auto-analysis will find some strings based on cross-references. But these particular ones it didn't find, and so there's no symbol on the destination. You'll see in this column. All right, so because we know that there's only one of these in the source that matches one of these into the destination, one-to-one mapping, we can basically accept all these. So I'm going to select everything and say, yes, apply the markup. That's the second one. One is just to accept, which does sort of a lesser version of that and says, yeah, okay, it is, but don't transfer anything. Here, I want to go ahead and transfer all that stuff. So I'm going to apply the markup. Okay. So why did it not apply there? Goodness gracious, Mike. I am not sure. Huh. Okay, I'm gonna have to look into that. Okay, so all of these guys here are now accepted and they're applied. Now we have some sort of a basis to be able to make references up through the functions that refer to these data and try to match them up. So what I'm going to do is I'm going to turn these off so that they're not distracting to us. I come over here to this light bulb and I'm going to say the exact data match. I'm going to turn that off. So I apply that, and now you can see I have 0 matches shown of the 3645 so far, right? So now I'm going to run one more correlator, and I'm going to say, let's do a data reference match. So what data reference match it does, like I said, is when a function refers to data, it sort of makes a fingerprint of itself. So I'm going to leave all these at the defaults, you know, that's fine just for demonstration purposes. And I'm going to say finish. And now you'll see that we have a ton of matches, which is pretty amazing. We have 625 matches from ARM to x86 just by using data referencing. Now, a lot of these things are, you'll see the purple here or the magenta. Those are external entry points that have to retain their names. But a lot of these, they're not, right? A lot of these functions were actually stripped when I ran strip on them. And you can see that they were found. So is this all hunky-dory? Can we just apply all these? Well, no, it turns out you can't, because there's this column here that says number of conflicting, and that says how many different functions are potentially matched to 2 different other functions in the source. So if we go and sort by this guy, we can see that we start up here and we go down to about here. Oh, darn. I thought that it told you how many were selected. Well, anyway, these are the ones that have no other options, right? So it's a very high probability that these are actually the right ones. So we can accept them, and it'll go through and rename all of the functions appropriately. Now, auto analysis is on, so all of the places where we we had laid down functions before. It's doing another reanalysis of them, and that's why it kind of took a little bit longer. So anyway, this is a really, really cool trick for being able to match things between different architectures. And it's something that only version tracking will let you play with, sort of in a playground. That's really sort of where it is that it's a great R&D type of tool for when you're doing matches. All right, so I don't want to belabor the point too much because I want to get to BSim real quick. But let's show everybody here the BSim correlator can be run from inside version tracking. So let's get rid of the one that I just ran, which is the data reference match. And now let's run the BSim correlator. And these are good. All right, so BSim, because of all of the data matches as well and the call graph that it calculated, did really, really well and came up with 2,049 matches. So if you look down here, yeah, so it's an amazing amount. It's like the vast majority of them, 1,800 or so, are without conflict. So that's the reason why everybody these days is probably going to be using BSim and the BSim database. So question is, sure, you might have one binary that you have analyzed and you have a new one that came out and you want to say, take all of the symbols that you analyzed already and map it to the next one. That's what version tracking is. But BSim is the evolution of that. By using the correlator and expanding it across multiple programs, you can now find the needle in the haystack by loading in a corpus of all of your executables. And now you can say, oh, okay, for this function here, where is it in the rest of the database? And that's what I'm going to show next. And it'll wrap us up here because I know I'm getting really, really long in the tooth. So I'm not going to save these guys. And I'm going to reopen Bash's pre-baked. Okay, so I have 4.3, 4.3 beta, RC2, 12, and 18 in here. I'm going to bring my shell back up and going to Bash's to import. So these are the known. So ignore this this bash x86. We're not going to be doing this anymore. But so we're going to say that we know about these 4 4s, right? And that's what's in here. But then we're going to say that we don't know about the 4 3, right? So, well, that's unknown. There we go. So I've got 4 3 stripped, right? Okay, so let me get rid of this guy. So hiding this shell script here real quick. This right here is what I did beforehand to import all of those files. Okay. So what you saw there, all those things in the bashes, this is how I did it. Now, I haven't shown you this directory, but it's basically the same as what I'm have organized. So you run the analyze headless script. You say what your project directory is. You say what your project name is, and then you say -import and then a particular directory. What it'll do is it'll go through and it'll import all those things and analyze them. In my case, it takes about 5 minutes or so to do all of these, and I didn't want to pay the price. That's why I pre-baked that. So now let's talk about BSim. How do you use BSim? Well, basically, the first thing you need to do is create a database. So that's what this guy does right here. If you go to, let's see here, let's go to help, content, and search for BSim. This has all of the stuff that you need to know about BSim, from enabling the plugin, defining and making the databases. There's a lot of information in here about being able to do it with like Postgres and Elastic and stuff like that. You don't need that. You can just make it with a file. And that's what we're going to do. So again, if you get lost in here, make sure and check the BSim help. But basically, this is what we're going to do. We are going to copy this, and let's go to BSim. Okay, I'm going to remove that. And we are going to paste this guy. And you might say, well, what is this medium 32? You know, what is that? Well, that's the model. It turns out that we're going to do a fairly small, i.e. medium number of functions in the 100,000s or so. And it's a 32-bit model, right? I probably should be doing this in 64 because it's a 64-bit executable, but it still works with 32. Anyway, then the second thing that you have to do is you have to actually generate the signatures for them. So copy that, paste this guy. Oh, goodness gracious. What did I do? Oh, yeah. So what did I call it? Let's take a look here. Bash's pre-baked bin. Bash's pre-baked bin. That's why they call it live without a net. So you can see that it's a lot faster than creating or than actually importing and doing the auto analysis. So that's why I left this as a step that you can watch, because it's actually pretty fast, pretty impressive. All right, all done. So I'm going to open up a code browser. Actually, first thing I'm going to do is I'm going to import that, the bashes to import unknown 4.3 stripped. And okay. So we'll bring this up in a code browser. We'll analyze it. Yes. Okay. So in this tool, we need to configure BSim to be a part of this, right? So actually, I don't know what'll happen if I do this while auto analysis is still running. So I'm probably going to wait. There we go. Okay. So once BSim has been installed as a plugin, or as an extension, which is in the help, then you can go into your tool and turn this on. And now you have the BSim menu. So let's manage our servers. Oh, that's from before, so sorry about that. Normally, you'll come up and the server manager is empty like this. We'll say, let's add one. It'll be a file. You go and browse, and I'm going to go to BSim, and here it is, bashes, and boom. Now it is a database that we can look at. So what does this mean? Well, let's take a look at main. Let's say that we're in this function and we want to know, does this match anything else that's in our database? Well, we can go to BSim and say, search for functions. So first thing you have to do is you have to select the BSim server. So we'll select the file that we just created. And we're looking for main. So it turns out that in all of the other known bashes that we have imported, it turns up that there's a main in all of those. And there's a function count of 1, and the confidence is out of this world, right? So it's almost, 99.9999% chance that this is the same main. So what if you don't know exactly which function you're looking for, right? Like, I'm down here in, am I still in main? No, I'm in this function. So I can perform an overview. And what this will do is it finds every function that's in the source. And figures out what are the matches, right? So some of these are very, they have a whole bunch of hit counts, right? So like return EOF, I can say search selected functions for that guy. And it'll say, well, this looks like return 0 or FIFO's pending or colon built in, right? So the only thing that really matches really well are the ones that say return EOF. But these are the other ones that also kind of match, probably because it's a very short function. But there are other ones that if we sort on the hit count, we know almost for a fact these are the same things. So unalias built-in is in bash 4.4 beta, right? So we know that this is the same one. So it's very powerful. Again, it's like finding needles in a haystack. If you have a particular function, you think maybe it's part of malware or something like that, and you have a catalog of malware that you've loaded into the BSim database, you might be able to say, oh, okay, I want to find this function. Is this anywhere? And boom, it'll just pop up. It's really like magic. All right, so I've been talking for a long time, and I see it's 8 o'clock, so we probably need to wrap this up. What do you guys think?
Well, I have a random question.
Sure.
When you were doing the version tracking, you had, I'm guessing the one was an ARM based and the other one was an x86.
That's right.
I don't remember which was which, but one of them had the functions had a bunch of labels and the other one didn't.
Yes.
Like, why is it struggling with one version? Or I don't remember if it was the x86 or the ARM or it didn't have the labels, but
let's bring it back up real quick. So this was down here, right? In the
yeah.
Oh, I didn't save anything. Let me run BSim real quick. That's hilarious. I'm guessing it's what you meant is the comparison down here from the source listing to the destination listing.
Well, I think it was when you did. I don't think it was. It was before you did BSim. I think it was maybe it was exact data match. I don't remember. It was one of those correlators you were doing.
Yeah,
and it had the list. Yeah, that. Yeah.
Oh, okay. All right. So let me hide this guy. Let's try the data one, because that'll go real fast. You're talking about the no symbol ones?
Yeah, like why did but like it would have symbols for one, but it wouldn't have symbols for like it would have symbols for the source maybe, but it didn't have symbols for the destination.
Yeah. So that's because I stripped the x86.
Oh,
Yeah.
You did say that. Okay.
Yeah. And so the use case here is that you found a binary in the wild that doesn't have symbols, and it's compiled for one architecture, right? And you're almost positive that this is bash, right? If you can compile bash for debug, even if it's a different processor, you can make a correlation between the two. That's sort of what this was showing.
Okay, that's pretty cool. That makes sense then.
Yeah, but honestly, it looks like BSim did just a knockout job on finding it between the two architectures, which is really a testament to how good the P code is. Also, the stuff that they do with the call graph and data matching is built in is fantastic as well.
Yeah, that's pretty cool.
So that's my hour and 45-minute like drop you into the deep end real quick.
Yeah, no, I mean I enjoyed it. Let's see, where's we'll bring Desync and Matthew back. I enjoyed it very much. I think this is something that a lot of people, they know what Ghidra is, but I think a lot of people struggle with it, right? And so at least for me, I thought this was very helpful.
Awesome. Yeah, well, thanks again so much for having me. I really appreciate it. It's something that I'm passionate about, and I hope everybody out there can take some time and get to know it. It's got a little bit of a learning curve, but once you get in, it's really pretty comfortable.
Yeah.
Well, we want to say thank you, because we couldn't do these types of events without knowledgeable professionals like yourself. So
sure.
Thank you for sharing 2 hours with us.
Sure. My pleasure.
Yeah. No, that's what I was going to say as well. We appreciate it. We know it's a time investment for everyone that comes in and does one of these. And we just appreciate you giving back to the community and like real actionable stuff. And this was great. I really enjoyed it. It's super helpful for me. A lot of things that I'm going to go Google later on. So, is very helpful.
Awesome.
But yeah, appreciate you taking the time. I hope we get to see you again soon. And anything from anyone, Matthew, Desync, Mike, any last words before we close out?
No, this has just been a real pleasure. Again, I thank you guys, and hope to see you soon.
Yeah.
Are you going to be at DAPCon?
I can't make it this year, unfortunately. I'm sorry. I've got my youngest son is going to college, and we have so much stuff planned over the summer. It's ridiculous. So
yeah.
Well, hopefully we'll be able to catch up with you at another con and give you thanks in person.
Absolutely. I'd love that.
Perfect. Well, normally this is the point where we would blow out your speakers with our outro video. I don't know. Should we do it or no?
Oh, me? You're asking me? Definitely. Oh my gosh.
All right.
Well, there's your vote.
Here we go. Outro video. You've been warned. Goodbye.
See ya.